Welcome to the tutorial, and today we have a body is projected horizontally from a top of a cliff 45 meters above the ground. If the body lands at a distance 30 meters from the foot of the cliff, calculate the speed of projection. Now, before you think of speed of projection, has to do with change of what? Distance with time. So in order to get your speed of projection, you need to get the time. And in this expression, time was not given, but distance was given. Before that, if you're not in my WhatsApp online class, WhatsApp me on 0815357 to join your full course on JAMB and WAEC. Price is 5,000 naira. Now, in the three equations of motion, you know that we have to get our time before we could be able to use this formula. We said that speed or u equals to distance. We want to use this expression, but we do not have our time. We have the distance. Now, to get the time, we are going to use the third equation of motion, which has both time and distance. The second equation of motion does not have time, but it has distance. But the first equation of motion does not have distance. So to get our time, we need to use the third equation of motion, and that was S. But now, since we are talking about height, which is a cliff, we are going to use H equals to UT plus half gt square. The g is because it's now going to be acceleration due to what? Gravity. Now, since the u is in initial velocity, now since we don't know it yet, we call it 0. We now have half a t square. Now, this is half a t square. In this, we are not going to say that the height, we are not going to use the height which the ball falls, because they say that the ball lands at a distance 30 meters from the foot of the cliff. We're not going to use this one. This is the motion of the ball. This is the distance of the motion of the ball. But why the height of the cliff is? So when we calculate the time, it's going to take a ball to fall from that height. Which this is the height, 45 meters. So this is the height, 45 meters. But here is the level ground. But when the ball was projected, as you can see, with the initial velocity that we do not know, which is what we're looking for, it lands on a point. Maybe this was a zinc, this is a roof zinc. So the ball lands here. It didn't land directly to the ground. But now, to calculate the time, 45, we're going to use the distance of the cliff to get the time it will take a body to reach the ground. You get? So that's what you're going to take here. It's going to become 45 equals 1/2, and the acceleration of this gravity was given as 10, and how multiplied by t squared. Now, half of 10 is going to give you 5. So half 45 equals 5 t squared. If I both side by 5, you're going to have 5 divided by 45 is going to give you 9, and you now have t squared. Now to remove the square, you root the both sides. I'm doing this so that I have my marker, because I think the ink is normal. Now we have 9 and you square it. It's going to give you equals 3. So the time is 3 seconds. Now that we have gotten the time, you could either use this expression, which is speed equals to distance over time, or you're going to use v equals to u plus at or gt, which is going to be your what? Your first equation of motion. Why this one in this point becomes 0? This one becomes 1, 0. Now in this case, what are we going to do? We're going to say, all right, u equals to d over t, so that u is now going to be equal d 30 over 3, and this equals to 10 meters per second. That is the first one. Thank you for